Right, so again, this is a phase 2 only part of the problem. We don't have to evaluate, so no phase 3. We're given the double integral, so no phase 1. So this is just, let's worry about the domain, and what is the domain, what are the bounds that come from the domain. So, okay, so x squared, y equals x squared, y equals x cubed in the first quadrant. Okay, so draw the picture. Okay, so y equals x squared is like this. Now y equals x cubed does something more like that. It's a little more blunt at the bottom and then steeper on the sides, and then likewise over there. So the punchline is there is a, actually let me do that in a different color so it'll stand out better. Yeah, so we're interested in this little region that's in between these two curves. And it's in the first quadrant. So, yeah. Okay, is everybody happy with the picture so far? Okay. By the way, a good thing to make sure that you're comfortable with is why it is that the cubic is below the quadratic. And a lot of students think, well, hey, when you cube numbers, they're bigger, so shouldn't the cubic be on top? But when numbers are between 0 and 1, cubing numbers makes them smaller.
Oh,
so you gotta kind of, it's easy to get that backwards, and a very common mistake is for students to get the bounds upside down in this question.
So how do we know it's between 0 and 1 in this?
Yeah, right. Okay, so we were just about to get to that. Let's go ahead and follow our usual procedure, and you'll see how that comes up very naturally. Right. So we've got an integral here. And by the way, let's decide first which way do we want to slice. Do you want to do dx or dy, or which do we want to do? This kind of sort of matters a little bit.
Oh, really?
Well, a little bit. I mean, it's not a deal breaker either way, but I have a definite preference. So keep in mind, whichever one you do on the inside, you're going to have to solve for that in terms of the other one, the one that's on the outside.
Oh, we
so
should do
So looking at these two equations, would you rather solve for y in terms of x or x in terms of y? And clearly we want to solve for y, right? Okay, so that means, we want y on the inside, exactly right. And that means we want dx on the outside, and then I'm going to go ahead and put the dy there anyway. Okay, so we're starting to think about range of values of x. So, well, here's what slices look like perpendicular to the x-axis. And so I need to understand that point and this point. Right, these are points where these two curves intersect. So these are points where x cubed is equal to x squared. And said differently, x squared times x minus 1 is equal to 0, and that's true at 0 and 1. Is that cool? Yeah. Okay. Everybody's happy? Okay. Now, what about on an x slice? Well, so we draw an x slice. Here's that little x slice for some particular value of x. And now I got to think about the range of values for y. So I got to decide what's the value of y there, and what's the value of y there. And well, good news. The first value of y that we're interested in, that point's on that curve. That curve's got this equation, and we've cleverly arranged it to where we wouldn't have to solve for anything in a weird way. So, it is. Sorry, I meant to make that black. The bounds in green. X cubed on the bottom, because that's the lowest value. Okay. Right. Okay, now next, the upper bound, that's on that curve that has this equation. Solve for y in that equation. And again, we've cleverly arranged it to where that would be easy. And that's x squared. And the integrand was just, I guess, f or something, right? Yeah. Okay, so there you go. Does that make sense to everybody? Follow-up questions or anything?
For the first one, I didn't know how to do it because the vertices of the triangle weren't like by the axes, so I didn't know what they.
Oh, for question 1 in this section.
Yeah.
Okay. We can talk about that if you'd like. Yeah. Are you good with this question though?
Yeah.
Okay.
Yeah.
Okay. Let me stop the recording here.